Hey everyone, welcome to my channel. In this video we are going to learn how to find highlighted text in images. So here you can see the result. If we have our initial image, you can see that we have found the highlighted text, we have created their bounding box, and using these bounding box we have found the final answers. We have converted the image into text. So you can see all of the 5 areas or the regions that were highlighted are now in a file, in a CSV file known as highlighted text. So we will learn all of this, and I have created a document as well so that we go step by step, and I have marked all the steps in the code as well. So we will have our original image, we will detect it with the color, we will find the contours, we will get the bounding box, we will crop all the images or all the region of interest, and then based on those region of interest we are going to convert the image to text, and we will finally save it. So all of this will be shown during this video, and we will go step by step, and I will explain how this procedure is done. So if you haven't subscribed yet, do subscribe to this channel, and I have also created a new channel about web development. So if you are interested in that, make sure you check it out. The link will be in the description, and all the files and all the code for this project will also be in the description. You can go on my website and you can find it in the OpenCV project course, and you will find everything over there. So without further ado, let's get started. Okay, so here we are in our Pycharm project, and as you can see, the name of the project is highlighted text, and we have a very few files. The first one is main.py, which has overview of the complete course, of the complete project, and then we have utilities, which has all the functions that will be the helping functions for our main file. So the image that we are using today is this test.png. So here you can see that we have 5 different regions that are highlighted, and we are going to find these out. So let's close that, and then we have this highlighted text .csv, in which all of these text will be saved once it has been detected and it has been translated from image to text. So if we want, we can delete that for now, and we can save it so that it overwrites or it creates a new one. Okay, so let's have a look. Actually, before we begin, let me show you what you will need for the text detection part. So we are going to use pytesseract, as you can see here. So the first thing you have to do is you have to go onto their website. So this is the pytesseract website, and I will put this in my website as well, the link for this, so you can find it there. And we are using the Windows version, so you can go here and download. Now you have the option for Mac, for Linux, so all the options are there. If you are using something else, you can download the relative binaries. Okay, so we will download this and we will install it. Now I have already done that, and once you install it, it will most probably install it by default in C, program files, and tesseract OCR. So what we are looking for is the file name tesseract. So this is the executable that we want, tesseract.exe. So we need the path to this file. So we will copy this. As you can see here, it's just C, program files, tesseract OCR, and then it will be tesseract.exe. We will copy this and we will paste it here. So this is my path that I have pasted, and you have to change these. And as you can see, you have to link this. Without this, it will not work. So once you do that, you can go to File, then you can go to Settings, and in Settings, we can go to Highlighted Text. And over here, I have installed, what did I install? I installed OpenCV Python. There you go. So this is installed, and I installed pytesseract. There you go. So these are the 2 things that I installed. The rest of them, they are installed automatically. and yeah, even NumPy, it's installed automatically, so that should be good to go. And then we can create this utilities file. So once you create this file, you have to import it. So as you can see here, I'm importing everything from utilities because I don't want to write utilities dot something again and again. So whatever functions we have, all of them are available to use here. And then we will import pytesseract over here, and then in the utilities we will import CV2 and we will import NumPy as NP. So these are the imports that we have to do. Once that is done, the first step, let me bring up the the pipeline or the overview. So here the first step is to get the original image. So we are going to first of all get our original image. So that we can do by going here to the main, and you can see this is the path file, and you can see here this is test.png, and here we are applying our step number 1, which is image is equals to cv2 imread, and this is our path. So once we do that, we can simply write cv2 dot imshow, and we can write original, if I can spell it right, and then we can write img. So let me remove that and let's run it. So this is the original image and it is imported properly, so we are good to go. So let's comment this. Okay, in step number 2, we are going to find the relevant color, and in this case we are using the yellow highlighter. So we will find out the yellow color wherever that is in the image, and then we will extract that part. And to do that, we will convert it into HSV space, and then we will use the inRange function to find the relevant color. Now all of this I have done in a lot of different videos in the previous projects, so you might be familiar with it. If you are not familiar with it, then I have a script for you here. I have added this just now. So this is basically the color picker. So all of this code, I have explained it in a previous video. What it does is it just grabs the different colors that you define, and you have these track bars in which you can define which color are you trying to find. So if I run this now, let me show you. So if I move this around, I should have some effect. There you go. So you can see that now it's detected. So this right now is, so here everything is visible. Then if I go here, then only the yellow part is visible. If I keep going, at some point it will disappear because there is a range. Now the thing is that this is computer generated color, so it's very even. Otherwise you will see some fluctuations, and you will have to tweak with these values to get the perfect ones. So once you get these values, you will get the HSV values, which are basically hue, saturation, and value. So for each one of these there will be a minimum and a maximum. So you will get these values, and then you will put it in our utilities function. In the utilities we have no, actually I put it in the main. So these are basically your values. So here we have the 3 minimum values, and then here we have the 3 maximum values. So here you can see here it's 0, 54, 74, and here it's 240, 153, 255. So this is what I did earlier, and I got good results with it. So I will keep this number. You can use this number as well. Again, because this is computer generated, there is quite a big range that you can use. Otherwise the range is quite limited if you're using a real highlighter or something like that. Okay, so once you have this HSV numbers, what you will do is, we have this detect color function. We will send in our image, which is our original image, and we will send in the HSV color values. So we are going to go to utilities, and in utilities you can see this is our detect color. So first of all we will convert it into HSV space. Now if you want to see how that looks like, we can remove this and we can run the main file. So this is the HSV. This is how it looks like. And then we can use the lower range. So we will write all the lower values here, and then we are writing all the upper values over here. So using this, we can mask, and we can use the in-range function to actually create our mask. So we have the HSV color space, and then we give it the lower and the upper color limit. And once it's done that, we can also generate using a bitwise AND, we can generate an actual result. So if you see the white image, let me just show you here so it's easier. So I will remove this one, and we will call this mask. So this mask will basically be a black and white image. So, and I will show you the result as well. So this will be image result, and I will say image results. Yeah, that should work. Let's run it. There you go. So as you can see, the mask is basically the white area, so it's black and white, and the image result is basically the actual image in those regions only. So that is good, and I can comment this out again. And now we can go back. So this was step number 2, and now we can move on to step number 3. So you have already seen that our masked image basically looks like this. So once we have this, but it's not really the edges, it's the complete thing, it's the complete color. So what we want is we want the contours. So we are going to find the regions that are present here, and we are going to find the contours, and based on these contours we are going to find the bounding boxes. So that is actually step number 4, but step number 3 and 4, they are done together. So we will find the contours, and based on those contours we will generate the bounding box around them. So we can go back here and we can go to our get contours function. Now this is a function that I created, and it's not necessary in this case, but it is helpful. So I did this in one of the previous videos, so I thought why not use it here as well. So we will give in some parameters. For example, I want to send in the image result, and I want to display the result on image, and then I don't want to show the canny. If I want to, I can write here true, and it will show me the result of canny. Then it has to have a minimum area, because otherwise it will detect noise as well. Filter is basically how many corners should it have. So in our case it should be a rectangle or a square, so it will be 4, and these are the values of the canny, the threshold. And then do you want to draw it or not on the image? So we do want to draw it, so that's why we are writing true. So once you do all of that, let's run it and see. So you can see the canny, so you can see the result of the canny. And then if we actually show the image contours, it will have the contours on it. So let's remove that, and let's write here image contours, and let's write here image contours. So there you go. So I think I removed the contours part, and I'm just showing the bounding box. Let me check. So this is the contour function. So in the drawing part, yes, so this is basically the draw contours. So I'm just drawing the rectangle. So if I remove that and I put draw instead, then it will draw the actual contours. Yeah, so it looks weird. I know it looks weird. These contours, they don't look good, but in any case we can use this and we can see the result. There you go. So how does this function work? Let's have a look. So first of all, we are sending all these parameters. I know it's a long list, but I didn't want to use two functions. I just wanted one function to do everything. Okay, so then the first thing we will do is this is for drawing on the image, so we are making a copy so that we can draw on it and it will not affect the original one. Then we will convert our image to grayscale, then we will blur it a little bit, and then we will use canny and we will give in our threshold, which is coming from here. Now these are by default 100 by 100, and over here we are giving different 100 and 150, so it will override this. Then we have dilation and close. This is optional, it's up to you if you want to do it. I found this to be a bit useful, so I added this. So dilation will increase the thickness and close will close any gaps that are in between these contours. So then here is the if statement. If show canny is true, it will run this statement, otherwise it will not run it. And once we have done all of this, we will send in our canny image, which is not actually canny because we have dilated it and we have closed it. So we will send our image close over here, and we will use the external method, and we will use the chain approx simple. So the approximation is simple. Now these are default parameters. You can learn more about these, but I have found the external one to be quite useful if you are trying to find the bounding box. So the outer region, if you're trying to find it, then external is the best one to go with. So once we have done that, it will give us all the contours and it will give us also the hierarchy. We don't really need that. So then we will take these contours and we will loop one by one and we will check their area. Now here we are going to check if it exceeds our minimum area, which will be defined over here because we want to avoid noise. So if it exceeds, then we are going to go further, and then we will find the parameter and using the arc length method, and then we are going to find the approximation. The approximation of poly count is basically how many corner points do you have. So if we have 4 corner points, that means that we have a square or a rectangle. If we have 3, it means it's a triangle. So this is basically if you have 4 points, it will give you 4 points over here. So we can check the length of this. So you can see here, if the length of this is equal to our filter, which is in this case 4, if we go here, you can see here this is 4, then only we are going to append to our final contours. So you can see here this is the final contours. So we want the results of only the ones that we have filtered. Now if it's not 0, then it will do this. If it's 0, then it will append everything. So either you define one filter or you don't define any filter, and in that case it will send output of all the contours. So this is what this function is doing. So once that is done, we can sort out all the values, all the contours based on their size. Now this is helpful in many different cases, but in this case it doesn't really help. So I didn't want to remove it because it's part of the function, but you can remove this as well. It doesn't really help. And at the end of the day, we are going to draw. So it's, if we want to draw, this is this flag over here, so which says draw is equals to false. So if it says true, then we will go through all of these contours, not the original one, not this one. We will go through the final one, the ones that we collected and the ones that we appended. So we will go through those, and then because we are saving the bounding box, you can see here we are saving the bounding box in our final contours, which is 0, 1, 2 and third. So this is the third element, so that's why we have this 3 here. So we are getting the third element and we have the x, y, width and height, and based on these x, y, width and height, we are basically drawing the rectangles. So it's fairly simple, and this is the image draw that we copied earlier from our original image, this one. Okay, so that is the idea, and we will return the image draw and we will return our final contours, because these contours are the ones that we will use to crop our image. So this was step number 3 and 4. And once we have that, we can try to print the length of our contours. So the ones that we are getting as an output. So let's run this. And there you go. So now you're getting the output as 5. So this means that we have detected 5 different areas. So we have 1, 2, 3, 4, and 5. So that means it is good to go. So then we can go to step number 5. Now step number 5 is where you crop these regions. So you take these regions and you convert it into individual images, because we need to send these images to our pytesseract and it will detect the text and it will give us the output. We need them as individual images. So in step number 5, we are going to create this ROI list. ROI stands for region of interest. So whenever I say ROI, I mean this region, and then this region, and this region. So all these regions are basically the region of interest, the ones where we want to crop. So those are the region of interest. So what we will do is we will create a function get ROI, and we will send in our original image, which was over here, because we want to get it from the original image. And then we are going to send our contours, because the third element of this contours is the bounding box. So we can take the information from that third element and we can apply it to this image to get the crop of our image. So we can go here, and this is get ROI. So we will loop through the contours, and for each contour we are going to do the same thing. We are going to get the X, Y, width and height, and we will create an ROI list and we will keep appending our image. So how do we crop? Cropping is very easy, because in Python you can simply use the slicing function. So here we are saying that we want to slice from Y, which is the first value, till Y plus H, and then we want to slice from X to X plus width. So this will crop that region and it will append it to our ROI list. So once it is appended to our ROI list, now it's an actual image. So if we say, for example, ROI list element number 0, it will be an image. If we say ROI list element number 1, it will be an image as well. So if we go back here, so actually let me show you. So we can write here cv2 dot imshow, and we can write here test crop, and we can write here ROI list, and let's say element number 2. So if we run this, and there you go. So it says here installation file. So that is, this is 0, this is 1, or maybe detected in a different pattern, I don't know. So that's why it's giving installation. Okay, so then what we can do is actually let me keep it here and I will comment it. Okay, so what we will do is, if you want to see all of these as outputs or as images, we can create a simple function where we can say display ROI. So here we are saying ROI display, and we will send in our images list. So we will go here, and in ROI display, what we are simply doing is we are looping, and we are saying for each ROI we are enumerating, because we want the value of X as well. We want to know how many loops did we add, because we want to give it as a name of our image. So because we cannot just write image here, because it will create 5 images, so it must have 5 different names. So for each name we are going to put the value of X. So it will be 0, 1, 2, 3. So that way we don't have to write down any static value. So here it will get the image. Basically in the list you have ROI as the image. So before we actually send it to display, I'm just resizing it, and this is because it's very hard to move that image around. It's just let me show you. So if you don't resize it, so these images are very small, and I cannot move them around. You can see I cannot drag them. This one, yes, because it's long, but others I cannot drag. So that's why I added this resize, otherwise it has no functionality. So if we do that, then we get a little bit of space where I can drag each one of these like this. Okay, so again, this is optional. You can just remove it from here and it will not display at all. And then we move on to step number 6. Step number 6 is the most important part, where we take our images, these individual images, and then we send it to pytesseract to give us the output of our image. So we need the text generated from that image. So how can we do that? Let's go back. It's actually fairly simple. We will create a list of highlighted text, and inside that we will add the text values. So what we will do is we will again enumerate the ROI list, and then we are going to use our ROI image, and we are simply going to use the function pytesseract.image_to_string. So this is the method image_to_string, and all you have to do is you have to send in the image ROI. That's it. So once you send in the image, it will give you an output. So let me show you. So if I copy this and if I paste it here, I can write print and we can print it out. So here you can see one by one it's detecting and it's showing us the result. So once we send it to pytesseract image_to_string, it will give us the output text. So if you want to learn more about this, I have done another video on detecting text from images, and I have shown in detail how you can detect only digits, how you can detect words, how you can detect characters and things like that. So if you are interested in that, go check out that video as well, or I will put it also in the link of this tutorial. So for this, I can remove this part, I can comment it, and instead of creating a new line, a new variable, I just put it directly, I just send it directly to append. So that's why it's directly written here, and this will save all these 5 values in your highlighted text. So that is the idea. So once that is done, so this was step number 6. Now step number 7 is optional. I have not added it here, but step number 7 is basically that you save that text in a file. So the file is here, highlighted text, and what you can do is you can go back here, and in the save text you can see that we are simply opening up this file, highlighted text, using the right tag, and then we are simply writing the lines of this text. So we are looping through these using the for loop, and then we are appending, or we are writing the values to this document. So if we open this up, you can see it's already there. So if I remove it and save, and if I run it again, you will see that it pops up again. So if I go here, you can see that this is shown again. So that is good. Now the last thing you want to do, maybe or not, maybe not, you can stack these images together to make it look a bit more nice, you can say. So what you can do is you can use the stacking function. So here is the stack images function, and this is one of the old functions that I wrote to stack different images together. So what we are doing is we are stacking a few images together to see the pipeline. So you can stack multiple images. For example, you can create it like this. You can stack the original, then the colored, then the contours, then the bounding box, the crop. All of these you can stack together. The crop has to be exactly the same size, so it might not stack together, but if you put all of this in one image and then stack it, that should work as well. So finally we can stack these images, and here we have the scale value, and here we have all the images that we want to stack. So we have the image result, and image contours, but again you can decide on what you want to add or remove. So if I run this now, and this is basically our stacked image. So you can see that all these 3 images are together. So if I wanted to show more, I could add another one here, or I could create a new row as well. So for the new row, you will have to create another array like this. So now you can see it's double, so you have 2 rows. Okay, so that is good, and actually this brings us to the end of the code, and simply we are using the cv2.wait key so that we can see all the results, and that is pretty much it. So all these files again will be available on my website. You can check the link in the description, and that is pretty much it. And I hope you have learned something new from this tutorial. If you have, make sure to hit that like button, and make sure if you haven't subscribed, do subscribe to this channel and the other channel that is for the web development, and I will see you in the next one.